Good morning and welcome to today's webinar. This is the second in our series focusing on industrial firewalls or security appliances as they're sometimes known. My name's Mike Lees, I'm the product manager. I'm joined today as usual by Chris Whitehead. If you'd like to say hello, Chris.
Morning.
So the last time we went through some of the fundamentals of firewalls. Today it's a good old-fashioned traditional product demonstration, which we make no apology for, and hopefully that's come across in the material that you've seen before the webinar. And we're going to focus on the Belden Eagle Tofino. Again, like the last webinar, we tried to position the material very much with the automation and control engineer in mind, maybe rather than the traditional, or network specialist. So, Chris, if you'd like to. So this morning's plan, I'm going to do a very brief recap on what we covered last time, and try and explain why we like the Tofino device and why we work with it. Chris is then going to take over, and within the constraints of what we can do within a webinar format, we're going to try and cover the main steps in configuring a Tofino unit, showing how it behaves when it encounters a problem, and I expect this to last around about 20 minutes or so. And we should have some time for questions at the end. It seems to work quite well if you can tap your questions in as we're going through the webinar, and then we'll answer these at the end, or maybe as we go if they're particularly pertinent to that slide. So this first slide here is really by way of acknowledging that to have an effective cybersecurity strategy, it goes way beyond firewalls. Firewalls alone are seldom enough, and I quite like this neat little graphic because it summarises it quite well. Firewalls obviously fitting within the technology sector, but without the operational processes, and the people, then really it's not going to be effective. Certainly, my personal experience is that security considerations now cover all aspects of industrial automation. It's got a major influence on the design as well as the ongoing operation of legacy installations. So today is all about firewalls, but clearly Solutions PT operate much wider than firewalls, so we're happy to talk about all aspects of cyber security. So where would we actually deploy the Tofino firewall? This is a fairly classic architecture drawing, and I think the normal way of thinking about firewalls is more of a perimeter device. Tofino is not really a perimeter firewall, it's about the center of the network, and as you can see here in the drawing, we've segregated the network into little zones, and what Tofino is all about is protecting these zones, and a zone could be as simple as a single PLC, or more typically it's a collection of PLCs and an HMI. The thinking really is to, when there is an incident, to limit as much as possible, such that the time from a failure or a virus is kept as short as possible. I guess this could be considered as part of a disaster recovery process. As you're probably aware, Belden do two firewalls. They do the Tofino range and the Eagle, which has been around for some time. And a simplistic way to think of the Eagle and Tofino is that the Eagle is really for the perimeter and Tofino for the core. As I said, today is about the Tofino. Chris and myself will be doing more webinars in the future around the Eagle device. So why the Tofino Xenon? And I've just picked a few points here, and these aren't technical points. I know from speaking to many of you that installing any firewall into a network, especially when it's a live network, is a real pain. And the last thing you want to do is actually stop, a system running. And firewalls have got a nasty habit, obviously, of doing what they're designed to do and stop signals getting through. One of the key design considerations for the Tofino Xenon is that you can install it in a live network without any interruption at all, i.e. it's basically a pass-through. I think this is called the test mode, Chris, is it?
Yeah, it's got a test state.
So it means you can install a Tofino Xenon and monitor for a while and then slowly start throttling back what information goes through. But the key thing for us, and the reason that we like it, is that you can stick it on a live network without any problems at all. It's designed for industrial networks. A lot of firewalls are what I'd call an IT firewall. It's been modified for industrial use. That's simply not the case with the Tofino range. It started off with industrial networks in mind, and this comes across in the drivers, the documentation, and the support. And in terms of the people that would use it, it's very much geared towards, as I've said earlier, automation and control engineers. Firewalls, it's a tricky subject. it's not possible to make it, completely a simple subject, but the Tofino goes a long way. And finally, the Belden brand. There's a lot of firewalls out there. Obviously, there's other firewalls other than the Belden brand. We like working with Belden. We get the support, we get the confidence in terms of product roadmap, and I think that's important, especially for security devices. Final thing before I hand over to Chris. Those of you that work with Belden products know that they're very functionally rich, which is great. But I don't think our Belden friends will mind me saying that it can make the products quite complex sometimes to understand and configure. They will do lots of things. To help get the right product, there is a specification tool on the Belden website which allows you to go through and pick the right functions that you need for a particular application. We found that useful, but Chris and myself have also put together a little pricing tool which we can send through to you. Just drop an email after the webinar, we'll send it through. And this allows you to build up your product specification, but it also gives you a feeling for the pricing as well in terms of adding the different options. So in terms of an introduction, that's all I really wanted to do. I'm going to hand over to Chris now for the next 20 minutes. So over to you, Chris.
Okay. Thanks, Mike. Good morning. First of all, before we actually move into the demonstration, I'm just going to give you a little bit of a background of the equipment we've actually got here today and what we're going to try and attempt to show you. So hopefully at the moment you can see the network diagram we've got up there. We've got the demo laptop, which is actually the one I'm working on currently. We have a single Tofino device and a single PLC. And I've also got a laptop that's not known to the network as well, so nothing that is actually related to Tofino, so essentially a contractor's laptop, which, as you can see, has got the skull and crossbones on there indicating the risk that it poses. Now also, because this is fairly visual, we've got a small IP camera as well, so when we go back to my desktop in a minute or two, you should hopefully be able to see the actual devices that we're working on. It's not huge resolution, but you should hopefully get a good indication of what's happening and what we're doing while we're moving through the demonstration. So, quickly come out of this slides. So here we go. We've got a very, very simple HMI here, which is a graphical representation of the demonstration board you can see there. So if I actually press a few of the buttons actually on the front of this demo board, we should be able to see the change in the data on the HMI interface. So as I increase and reduce the demand, we can actually see that there's live data flowing and the PLC is doing its job to maintain their tank levels. So what we're going to start with is actually the Tofino configurator, which is the key piece of software used to configure and test your Tofino devices. So these actually have a handful of options before you even get into modifying or changing anything. It's around the actual project creation. So very simply, we're going to create a new project file today, and we'll just call this one Tofino test. You can give it a local name, you can give it something logical if you're working on multiple projects. It's probably worthwhile having a reasonable naming convention if you're working on more than one device. Okay, with the projects, we've got a handful of options around how we protect the information that's in there. So it'll stop it being modified by people who don't have access to it, or actually protecting it from internal teams as well. So there's two ways of protecting it. One is with the embedded license activation key, which you input when you install the software, and the second one is via a password. So if we wanted to, we could put a password in here, and then each time we try and open this project, we will have to re-enter this password. So for simplicity, I'm not going to bother with the password for now. We're just going to leave it on the license activation key. So this is a fairly open approach to working on a project, and it's not hugely secure. We've then got options around having administrator passwords. So in a collaborative working environment, you could have a few people with administrator rights to be able to modify and edit the project, and people with just the basic password who've just got the rights to open it and only view it. So for review, considerations, etc., you can tier your layers of security to give you the functionality that you need with the software. Okay, so this should open up in a second or two, and this is a completely blank project so far. So what we're going to do is talk around some of the structure of the actual the interface, and then we'll go through adding a Tofino and doing some testing and show you how some of the functionality of it works. So the Tofino configurator is broken down into a few areas. One, we've actually got the Tofino Security Appliances. Now you'll see there's currently nothing in there. This is completely blank, and the Tofino we're working with today is completely brand new out of the box. It's never been used before. So we're actually going to go through discovering the Tofino, adding it to the project, and then doing the configuration for it. Okay, we've then got assets and asset templates. Now these will simplify your life when it comes to actually creating your firewall rules to configure the Tofino. So essentially an asset is a list of devices, protocols, and any other specific information you need. So you can literally use a drag and drop interface to drop the assets into the firewall rules to do with the configurations. Now, it does sound like a lot of work creating an asset for each and every device you've got out there. So what Tofino have actually done is created a whole host of asset templates. So these are predefined assets that actually have got all the pre-specified rules for it. So for example, if we open up the Inventis Wonderware HMI, we can see that if we use one of these templates, it's already got the protocols necessary and the permissions for these devices to function. So there's an absolute immense list of all these different devices, controllers, from brands to the individual devices in there. So these are a good starting point. So if we wanted to deploy a Wonderware HMI or any other HMI, we can use one of the templates that's in here. But likewise, if we're doing mass deployment of the same assets over and over again, we can actually make our own templates. So we can actually right-click on one of these and we can create a new asset from the template, so we can deploy a single instance. Or we can actually create a new template. So if we create a new asset template from here, we could call this Wonderware 2 as an example, and we can fill in whatever information we want in there. We could say, well, this is a type of HMI, and we can fill in as much or as little information as you need. This then creates a second asset from there, and then we can add whatever protocols on that we wanted to. So we could say, well, this one just uses common industrial protocol of, if we can find it, Modbus TCP. And that needs to be allowed. So now each time we deploy this Wonderware 2 asset, these specified protocols will deploy automatically with it. Now I've deliberately left the IP address of that device blank because obviously each time you're going to deploy it, it's going to apply to a different device, and realistically the only time you need to fill that in is when you're actually going to use it. You're never going to deploy the same device with the same IP address consistently. So that allows you to actually create templates, or likewise if you're only doing a handful of devices like we are doing today, I'll actually create just a simple template. So if we open up an asset here, and we just right click and create a new asset. So we'll call this one demo laptop, which is the machine we're working on. And I'll just put in here HP because I've got two laptops which we're using today, so I'll differentiate them by the manufacturers. And this one we're just going to give an IP address. So this is 192.168.1.15. I don't need to know the MAC address of the device. I can do this purely off the IP address. If you're running your systems where you're not using IP addressing, then you could just use the MAC address of the device if you know that one. Okay, so that's created the asset, but again, I've got no predefined protocols assigned to this one because I don't really need to use anything with it. So if I did want to force something, I could say, well, actually, I need to add in common IT protocol, and just for the sake of the test, we're just going to do something like pings, and we need these to be allowed from this device. If I want these entries logged in the firewall and the event logger, then I need to tick the box. There's no complex script into it. It's just a case of put the tick against the things you want to log. Okay, so now we need another template, which is for the actual, for the PLC. And now we're using a Vargo PLC. So I'm going to tell it this is actually a controller. Keep that simple for now. And this is on 192.168. Oops. And I think it's on 1.1, so that should give pop that in there. Okay. Now I'm not going to add any specific protocols for this one. I'm going to leave this one completely open because when we create the firewall rule, we can specify what protocols are protected and used in the definition. So I'm actually not going to add in the third laptop. So I don't want the system to be aware of this laptop. It's going to be completely unknown to the Tofino. So this is the contractor laptop that we showed you earlier on the network diagram. Okay, so we've now got the two assets, but we haven't got a Tofino. So although we've got the assets defined and we know their IP addresses, haven't got a Tofino to actually start building the configuration on. So with this system here, I'm actually going to now find a new Tofino. So I'm going to go to the discovery system because I don't know the MAC address of the device, and I'm not going to try and read the little tiny print that's on the front of the box. So what we're going to do is actually passively scan the network for the actual device that's there. So the Tofino itself, if you've seen our earlier webinars, you'll know doesn't have an IP address. So it's not something I can directly specify. I need to use or borrow an IP address of something downstream, in this case the PLC, to be able to actually scan that IP address and find the Tofino that's there. So I'm going to start my scan at .1, and I'm not going to waste ages and ages doing this, so we'll very quickly just tell it just to scan 3 IP addresses. Get rid of them. So I'll start this now, and you'll see pretty much instantly it's picked up the Tofino that's there. It's added it to the Tofino Security Appliances list on the left. So if I open this one up, I've got three basic settings, one for the general, one for the event logger, and one for the firewall LSM. So if I open up the general settings, we can see the MAC address that's been detected of the device. We've got a local name here, so we can call this whatever we want. So we can just call this test Tofino. And we can put locations and specific details and anything that you actually want to in there. We've then got the operational current state of the Tofino. Now this is in its test state, which Mike mentioned earlier. Now this means we can configure the rules, we can do our syslogin, we can actually look at all the information that's coming back off this device, but it does not do any filtering. So in this test state, it's safe to put this into a live network. We can test and configure all the rules we want, but it will not stop the data from flowing. So if I just minimize the configurator for now, we'll see even though we've got the Tofino technically in the network and it's actually plugged in and connected, the data to the PLC system here is actually still working. So I can still update this HMI and change the tank levels and everything's working as it should do. So we've actually got a live firewall in place in its test state with no loss of data or connectivity to the devices that are behind it or in front of it. Okay, on the right-hand side here, we've also got the communication method. So this is how we're going to pass the information to the Tofino to configure it. Now we've got this one enabled with the Net Connect LSM. LSMs I'll come to in a couple of moments. Now this means we can do this passively through the network. If you're not using this or your Tofino is installed in a standalone network or isolated section of the network where there is no network connectivity from your configurator to the device, we can actually use the USB option. And now this means we actually put the configuration profile onto a pen drive and we physically have to load the pen drive into the actual device to load the configuration. It does add a few steps to it, but it does mean that if you have a very isolated, protected section of network, you can still use these devices with no real issues. But for the sake of simplicity in the demo, we're going to leave it on USB and network. Okay, now the last section on this page is the LSMs, Loadable Security Modules. These are the additional licenses you saw in the earlier configurator screens that give you the additional functionality and specific deep packet inspection modules for the specific protocols. So we've pretty much got one with everything here, which is the Net Connect, we've got the Firewall LSM, we've got the Event Logger. Now we've also got Modbus, which we're going to do a bit of a deep dive into later. We've got the OPC Classic and the IEC 104 for substation use. Now you'll see we haven't got the Ethernet IP one used on this, which means because there's no little key there, I can't use it. So even if I have a ticket, it will not give me the options to use this module because it's not licensed. So if we needed to, we could add another license to it and basically update the firmware on the device that gives us this license. But that does show you the difference between licensed modules and unlicensed modules. Okay, so we've got the next tab down on the Tofino is our event logger. So this is basically where we're going to output all the event logs from the system. So I need to point this at an IP address of the syslog server. Now, again, for the sake of the demonstration, having as many computers in the room as possible, we're actually running the syslog server on this laptop. So I've actually got down here, and I can find it, a very, very simple syslog server. It should open up in a second or two. There we go. So completely open, this is just a real simple free version, but it will give us the messaging logs that we need to see. So I need to point this at this IP address of this system, so this is 192.168.1.15. I don't need to put a gateway address in there because obviously we're not routed out across the internet for this one. However, I do need to assign an IP address to this Tofino instance. Now, it doesn't give the IP address to the Tofino, it purely prefixes the messages from this IP address. So the Tofino itself doesn't have an IP address and has no attackable web interface, but it does need a defined IP address. So when it inputs the actual messages into the syslog server, you know which Tofino it's come from. If you don't put one in there, they just appear from a 169.254 address, and you'll never understand where your error messages are coming from. So if we just give this one a .3 address, so 192.168.1.3, and I do need to put the subnet mask in here. Now what I'll actually do is I'm going to quickly change this and just make a mistake. Now you'll see at the top of the page, the Tofino configurator has some logical rules that can apply to your configuration. So if there is a deliberate error in there, it will highlight it at the top and it'll tell you that there is a problem. So it tells me that the subnet mask isn't valid. So actually, if I correct that, you'll see the error message instantly disappears. Okay, so now on to the firewall. So what we do, we'll open up a real simple one to start with. We're going to basically do a sanity check so I can actually ping the PLC and make sure that communication's working. Then we'll perform a couple of tests, and then we'll move on to doing the Modbus work. So again, logical rules are applied at the top, and it tells me that the NetConnect LSM is not going to function properly without this ARP rule created. So I don't actually have to go in and manually create the rule. I can click on this, and it will automatically put the rule in that I need to make this work properly. So now we need to add in a rule so I can allow this laptop to ping the PLC and see the responses from it. So I'm actually going to click on the button to create a rule, and we're just going to create a standard type rule. Now this is where the defined assets we did earlier will make life much easier. I don't need to bother with putting IP addresses in or MAC addresses. I can literally pick a device. So I can say, well, the demo laptop wants to talk to the Vargo PLC, and then I can actually choose the direction of flow of data. So I've got left to right, right to left, or bidirectional. So you can configure these whichever way around you want that's going to suit the protocol and the application you're trying to open up. So we're going to leave this as bidirectional, and we're going to carry on through. Now we're going to manually create a firewall rule for this as well. So we actually just want to open up a common IT protocol, which is the ping-only one. And I want it loud, and I also want it logged. So we've entered the syslog data earlier. So if I make sure that's there, and now just press finish. So what you can see is it's now added in the secondary firewall rule. Again, this hasn't actually passed it to the Tofino yet. It's purely we've built the profile. So now we've got the one rule in there we want to test. We go back to the actual Tofino header at the top, and I've got the apply button. Now, because we've got the NetConnect LSM and we've got this configured to work over the network, this should actually just push this straight out across the network, but it will ask me to save the project file before I do this. So you're never going to end up in the situation where you've uploaded a profile to your Tofino, but you haven't saved a copy of it first. So you're never going to end up where you've got a newer project on the Tofino than you've got available in the configurator. So actually, we'll just call this one test one. I'll overwrite the file that's there. Okay, so it's now going to save the file. Might take a couple of seconds just while this actually uploads. So we'll make sure that the test Tofino is ticked there, and we press finish. Now this is basically sending a packet of information to the PLC downstream of this. That's not ideal. Where's that failed? Oh, there we go. You see the error message actually appeared is because I ticked the Ethernet IP box in there previously. So that's actually quite a good demonstration. If I come back to the settings and untick that, it basically warned me that I'm trying to enable an LSM I'm not licensed for. So wait for it to save this file again. Hopefully it should work this time. Fingers crossed. So again, it's opening the connection to the PLC with a small amount of packet of information that's picked up by the Tofino when it's scanned. That actually says, no, this information isn't for the PLC, it's for the Tofino. The Tofino then opens its SSH session, the files and the configuration are uploaded, applied to the device, and then saved. So this hopefully should come back in a second or two and say success. It'll take a second or two, unfortunately. It's always the way. As soon as you start doing these things in a live demo, they feel like they take 10 times longer than it would do normally. Okay, so while that's actually working, if I go back to my syslog server, we should actually start seeing some information now. We're getting a whole host of messages being pumped into there, quite a few actually, 134 so far. And it's basically anything that doesn't fit the rules we've created is basically being logged. So what we'll have to do is put a sanity rule in there. So what I want to do is ignore all the messages and traps that are being created by the standard Windows software, so like things like my antivirus trying to update and Skype trying to find its way out to the internet for a connection, and anything else that's going on there. So what we want to do is to have just relevant information in the syslog server. It's pointless being filled up with thousands and thousands of error messages that are happening every couple of seconds. We only really want to see the messages that are critical to what we're doing. So when this is finished, which seems to be taking a little longer than normal, what we'll do is we're going to just have a quick look at the error messages that are in there, and then we'll figure out what firewall rule we need to create to actually ignore the bulk of their messages, because we don't need to see them all. So, okay, we can see that's now been successful. It took a little bit longer than I anticipated. So we can actually see what version of the project revision we're working on, because each time we've changed this and we've saved it, it's updated it. So I can see that I'm on revision 4. That's worked properly. So if I just minimize this now, we can still see that the lights are flashing on the PLC, and also my HMI is working as it should do. However, I can see that, if you see that at the bottom of the screen there, 280, 290 messages an hour coming through at the moment. And it's all stuff that I really don't need to see in there. So what we're actually going to do is create a firewall rule that's going to stop all these. So go back to my firewall rule there, and we're just going to create a new rule. And it's a standard rule that says, well, any device that's any, and it's basically any UDP packets, I want it denied, but I don't want to know about it. And if we just go back and quickly apply this one. Now hopefully this shouldn't take us long this time, because it's already got the configuration on there. We're only making a minor change to it. We're not uploading the full profile again. So it should take a second or two. Now I'll wait for it to finish, then we'll go back to the syslog server and we'll clear down the logs that are in there, and we'll just make sure that we're not seeing tons of information coming through. He says.
Chris, the reason it takes a while, isn't that to do with the communication protocol?
It is, yeah. It's very, very secure. So the actual information, because the Tofino device doesn't have a direct connection to it, it's constantly trying to pass packets to the device downstream, and the Tofino intercepts them, scans them, and says, well, actually, this is the configuration for me, accepts the packets and doesn't hand them down to the PLC. So that one didn't take as long. That's now done. So if we go back to the syslog server now, we clear these out. Okay, so I'm still getting a couple of messages appearing through there. It's coming on there. Okay. So basically we're still seeing quite a lot of messages appearing. And that's because the device is still in its test state. So we're filtering stuff, but we're not actually blocking it at the moment. So what we'll do is we'll just quick sanity check and make sure that the actual rule is working properly. I should have my command prompt open. So that is actually allowed through, and we should see them in the logs. They'll appear in a couple of seconds that it's actually permitted that information through there and it was logged. Okay, so if we go back to the actual Tofino device now, I suppose the next step is I actually want to see what happens while the Tofino's in its open state, if you like, and we bring in the contractor's laptop and we open up a spurious file that could potentially take down the PLC. So if I minimise this here, just minimise that for now. So we can see the IP camera and we can still see the board. If I hopefully pop this second little laptop just into the display there, and all we're actually going to do is have a very, very simple exploit on here. If I open this up, it's just a PDF file, which is the manual for the actual PLC. And we've embedded a little bit of code in there. What will actually happen is it runs this suspicious payload, and you'll probably see now that the PLC lights have gone crazy. The actual system's gone into essentially a shutdown state. Well, if we come back to the desktop, you'll see that my HMI still appears to be working properly. That doesn't show anything out of the ordinary. I can still see that the data lines are moving. I can still see the tank levels working okay. But looking at the actual PLC in real life, we can see that that is specifically in a terrible state. That's gone horribly wrong. So unfortunately, what I need to do is quickly power this device off, because there's no way of recovering from that. And what we're going to do is bring these devices back up. And now what we're going to do is essentially put in the protection rule that we need to protect the HMI that we're currently working on. So this is more of one of the LSM configurations, which is around the Modbus rules. So we're just going to give it a second or two just while the Tofino and the devices restart themselves. Okay, so if we go into the firewall rule now, we've already got the laptop and we've got the PLC added in there. So we're going to create a new firewall rule this time. And we're actually going to say, well, the laptop needs to talk to the PLC, and it's just one directional traffic. I don't need information back from the PLC, it's just purely passing information. However, this time, when we manually create the rule, we're going to use a common IT of Modbus TCP, common IT industrial one. So we select Modbus TCP, but this time we're going to use the enforcer module, which is the LSM we've licensed. Now we want to know everything that happens when we apply this. So now we've created the rule, and we can see it's an enforcer, but we haven't actually configured anything specifically with it. So what we need to do is go to the enforcer tab at the bottom, and we're going to go to the advanced protocols here, and we've actually got all the functions available in Modbus. So So there is an immense list of them in there. Now this one specifically, the one we've just attacked, trips up by injecting a holding register that's outside of the specified values. So we're just going to quickly input these details here. And you'll see if I leave a number out or there's an error with it, the sanity checks within the configurator will show me that this number must be valid. So if I put in the other number that needs to be in there, which is 12637, okay. So only really need the one that's on here. So we've now got a handful of rules created for the actual Tofino, a couple of standard IT ones, and one specifically for the Modbus protocol. Now if we go back and we apply this, okay, again I've got to save the project file before it applies it. We'll just give this a second or two while it updates, make sure everything's working properly. Again, it shouldn't take too long this time because we're not uploading the full profile, we're just simply adding one or two little rules to it.
Just while it's doing that, Chris, we hear a lot about deep packet inspection. Is this a practical example of deep packet inspection on a Modbus TCP?
I would say it's an absolute example of deep packet inspection, yeah. It's essentially what we're looking at is not just where the source of the data is coming from and it is validating the end path of the actual result. We're looking at what's in the packets. So not only the shape and the size of the packets, but then the content within them. So this is much more than just like a stateful inspection. This is true deep packet inspection. We're actually looking at the information within the packets and applying the logical rules we've created and understanding the Modbus protocol to it to give full protection. Sorry, just grab a quick sip of water there. Okay, so we've actually applied this, but what you'll need to remember is we're doing this still with the system in its test state. So currently, we would see that logged if we tried to stop it, but what we actually have to do is go back to the Tofino's general configuration and now tell it it's in its operational state. So now when we apply this time, what we're actually doing is meaning that the rules we've created and tested and looked at in the logs are now being applied properly. So this is where if you've got any errors with your rules, you'll spot them straight away because it'll start blocking data. So until this point, we've done it in a completely safe environment. With, the more time you spend creating the rules and fine-tuning them, the better your overall protection is going to be. You're not going to inadvertently block stuff that needs to be let through. Likewise, not going to let through stuff that should have been blocked. So at this point, this is the final switch to throw, if you like. This is where we're happy with the configuration. We know things are going to work properly, and we're going to set it to its operational state. So if you do find you've made a mistake at this point, it's still not too late. We can actually go back and just put the device back into its test state and carry on working on it. So it's not a one-time thing. It's nice and easy to come back out of if you need to make sure that everything is working properly. So again, now what we're going to do is, if I just rerun the exploit on the little laptop, so I'm going to push it back into view of the camera there. Okay, and we can see that I've still got the HMI working on the screen. We're going to open up the same exploit file we just have run and still ignore the security warnings telling me don't do this if you're in trouble. And this time what you'll see, the same messaging and payload has been delivered to the Tofino, but it has actually just computed through it. It's rejected the files because they don't, it's rejected the exploit because it doesn't fit the rules we've created. And if I can get back to the event logger, I can get rid of that. So there we go. We can actually see where the device has been set operational. We're still getting a couple of error messages appearing in there, and we've got this one here saying that the device is now operational and packets have been blocked because of that. And there's quite a lot of messages in there. We didn't clear it down fully before we changed it last time. But the same exploit that we previously tried to run has been run again this time, and you'll see that everything's still up and running. The PLC has computed through it. The error messages are raised to syslog server. Now, it depends on the syslog technology you're using, but if you have a slightly more advanced syslog server than the one we've demoed, then you could actually raise your own alarms, internal alerts based on that, and react to the security incident that's been raised. So all in all, that is pretty much as we've got the limitations being able to demo today. But if you've got any questions, please feel free to ask them now or contact us after the webinar if you'd like to discuss this in any further detail.
Chris, thanks very much. Always brave doing a live demonstration on a webinar, I think. I've not seen any questions come in through the webinars we've been doing it, so we'll just wait a few seconds, see if anything. we've unmuted the lines for those people who've joined by telephone if you'd like to ask a question, so we'll just wait a few seconds.
Yeah, so if you've got any questions, probably now's the time to throw them out. If there's anything you'd like to see specifically, you know, while we've got the equipment up and running, we can very quickly try and show that. If it's something hugely technical, I may ask that we take it offline and we'll address it after the webinar for you. Okay. One of the questions from is, hi Chris, can you go over again the difference between the allow and deny enforcer in permission field of the device? Certainly. Okay. So what we've got, if we open up one of the laptop rules there, let's have a quick look at this one, which is just the pings, probably the easiest one to play with. Actually, no, let's just create a new one, it's easy enough to do. So we'll pick one and we say the laptop, and we're going to pick the end device, and we're going to pick the flow of traffic. So this could just purely be bidirectional traffic. We're going to manually create a firewall rule, and we're going to pick one of the protocols. So let's just say any IP there. Okay. So what we've got is an allow permission and a deny permission and the enforcer module. Okay, so in this instance, because we're using a common IT protocol, there isn't an enforcer module. So if we were using one of the LSMs, for example, OPC, Modbus, Ethernet IP, or one of the IEC 104 modules, then this is when we can use the enforcer options to essentially understand the calls and functions, commands that are within there to ensure that, you know, we're applying the necessary rules to protect the devices. In this instance, pretty much the two options we've got is the allow and deny. So if we want to specifically allow any TCP traffic through, we'll tick this box. If we want it logged, we simply enable the login. Likewise, if we want it denied, you know, we don't want that information getting through, then we tick the deny option. And if you want it denied and logged, then you tick the box. So as we created the example previously, which was this one, which means I wanted to ignore any UDP traffic that the system would see. So I created an any-to-any rule, and we sold it, well, any UDP traffic, I want to deny it, I don't want to know about it, but likewise, I don't want it filling up the syslog server. I don't need to know when it's blocked things like Skype trying to talk to everything on the network, or, you know, when antivirus updates are trying to push out, or when the Windows update services are trying to run. So essentially, you specify the permissions based on these devices. So if you wanted to then if you had multiple devices, you could then pick, you'd have multiple rules. So laptop 1 can talk to PLCs 1, 2, and 3, etc. And then you can specify which protocols it's allowed to talk to, which ones it's not allowed to use. So essentially, it comes back to the security zones and conduits theory that we talked about earlier, and we've also done on the previous webinar, which is where we're only using the Tofino to create a conduit, so only the bare minimum amount of information flowing through the zones to give the functionality that you need. So I hope that answers any questions. Okay. Next question I've got is, where in the network physically would see the ideal place in placing the units? Realistically, the devices are one-to-one, so there's one input port, there's one output port. I would say that if I can just go back to one slide a second, so I'm just going to quickly dive back to the presentation we had earlier, and I'm going to pick on that one there. No, not that one. That one. Okay, so hopefully you can see the defense in-depth firewall slide. Now, in your network, it may not be possible to actually have a Tofino in front of each and every device, purely, you know, if you've got a lot of devices or if they're in groups. So your Tofino should be the last line of defense before the PLC, DCS, or group of devices you're trying to protect. It's going to sit right down in the core layer, in the core of the network, nowhere near the edges. So this is essentially right down in the very center of your PLCs, and realistically, you would never have it with a switch downstream of it, regardless of how much you need, you know, more ports behind it. If there's an ingress point behind the Tofino, then the Tofino is pretty much pointless. And typically, we'd say that you protect a maximum of kind of 3 to 5 devices per Tofino, purely for the time it's going to take you and in actually configuring the rules, but also the limitations in the network throughput of the device, being able to scan all the packets in its full detail. Okay, so. Yeah, and also just another question as well in the room, which was, yes, you could actually use it one-to-one. So if you've just got one PLC like we've got here, and you've just got one device there, it would literally sit right in front of it. So as we've physically got it connected here, you can see through the webcam, which if I come back out of that presentation. So we've got from the switch, we're going straight to the Tofino, and then directly from the Tofino to the PLC. You could geographically separate them if you want. There are obviously limitations on how far you can run your network cables, but it's possible that you could actually have them in, they don't have to be directly next to each other, it could be separated wherever you need it to be, as long as there is no switches or anything else in between there. Okay, I've got another question. In your experience, have you tended to configure Tofinos over USB or via the network deployment you've demonstrated? If networked, where, which layer on your architecture slide would you have it, and would it be dedicated for this purpose? In all fairness to that question, I've actually had scenarios where we've used these in both. So we've had some people that have them on completely isolated networks where the configuration's over USB. The difficulty is in the fact that, you know, there's a manual job involved in save your profile to the USB pen drive, walk down to the actual device. The NetConnect LSM does mean that you can just push it out across the network, and that tends to be, if I'm being honest, the preferred flavor. Because when you're setting these things up and you're constantly changing and tweaking your configuration in its test state, it means you're not wasting time continually moving around the plant and actually, you know, uploading the configuration and testing it and re-evaluating the logs. As to where it would sit on the actual architecture, if we go back to this, it could actually be anywhere from the in the upper layers of the network. So anywhere around your workstations in there. It doesn't actually have to be, as long as there's routed connectivity between the devices. So as long as, for example, like this contractor's laptop that's here on this slide. Let me make it full screen again. So like the contractor laptop that's there, or one of the workstations, as long as there is a route through to the PLC and you can see that there, then that will work. I say it doesn't actually have to be in the same network. It doesn't have to be down there on the plant network, on the control network. As long as you've got visibility of it and you can get to the devices you're trying to protect, theoretically, it will work. So there's no limitations over where it sits. Okay, I've got another question, which is, are there any test scripts that Belden Tofino release for network stress testing or advice on security testing? Quite simply, yeah, there is loads of it. It's such a wide subject. What I might actually do, Mr. McLaren, is if I can speak to you after the webinar, we can probably give you a whole load more information on that, because it's such a broad subject. Yes, in quite simply, there are loads of test stuff out there, and there's loads of certification tests that Belden have had the Tofino tested to currently. But if it's something specifically you'd like to ask, then we'll catch up after the webinar and we'll address them questions for you. Okay, and I've got one more question to put at the bottom. It says, what's the packet scanning rate capabilities, i.e. how many? It is...
Well, Chris, as you probably know, there are stats released by Belden in terms of testing the specific LSM, so we can send that information.
Yeah, exactly. I was just about to say that. It does vary based on the LSM. So the difference with kind of industrial IT protocols, you're talking theoretical rate of the device, which is like 1,000 packets a second. If you're using the more complex LSMs, which understanding the protocols, commands and functions, there are some differences. But like Mike said, we do have documentation that shows the differences between where the test results are at based on the different LSMs and modules. So we can share that information with you after. Okay, can you multi-broadcast rules to a number of Tofinos? Yes, quite simply you can. If I go back to the configurator, we've only got the one device configured in there, but if we had multiple devices, when we actually go and we apply the rules, I'll wait for it to save it again, you'll see that I had a tick option around just the one Tofino. If I've got multiple Tofinos in the project, I can simply tick the ones I want to push the project out to, and it will apply it to all the necessary Tofinos. Quite simply, it's a nice easy one, that one. Okay, have we any more questions?
I think we're sorted.
I think that's it for now, but I say if there is anything further, if there's anything specific you'd like to ask me, feel free to contact us after the webinar, drop us an email, give us a quick call, and we'll do our best to answer the questions, and we'll share as much collateral as we've got with you that will help answer them questions. So thank you everyone for your time, it's much appreciated.
Cheers Chris, thank you. Bye everyone, thanks for joining.